First, we draw a buck converter with the source, a switch S, and the inductor L, a capacitor C, a diode D, and the load R. We have some basic variables: the input voltage V in, the output voltage V out, the inductor current IL, the output current I out, the capacitor current IC, the cycle T with the frequency F. On a steady state, we have two phases. When the switch is closed, we have this circle. The current in the inductor increases. The voltage of it equals V in minus V out. When the switch is open, then we have this circle. The inductor current drops and its voltage equals to minus V out. So in a steady state, we know the current and the voltage waveforms should become periodic, which means the IL at the beginning of a switching cycle should match that at the end. I name this point as I min and the switching point current value as I max. The current ripple data IL should be I max minus I min. Since I max can be calculated with the slope of this on-phase line, multiplying this time duty plus I min, we can calculate the ripple current this way. The same way we can get the ripple current on the off phase. It equals to this inverse slope multiplies the time 1 minus dt, and we remove all the L and T. We got this formula V out equals D times V in. The average capacitor current is 0, thus the average IL is I out. To calculate the C, we know that the C equals delta Q by delta V. Delta Q is the change of the charge in the capacitor. Looking at the IL, we know that when the current is above the average, it goes into the capacitor, and the below means the current goes out from the capacitor. We just need to do the integrals of the current on the half of the time to get the charge, which is half times half time times half delta I. That makes T delta I by 8. We bring it back to the capacitor so that C equals to time delta I by 8 delta V. Now we have three important formulas to remember. We can start to do our exercises. The first one has conditions below. V in equals to 45 voltage. Frequency is 25 kilohertz. The inductor is 1.5 millihenry. Capacitor is 220 microfarad. The resistor is 8.25 ohm, and the duty is 0.55. We need to calculate the average inductor current and the current ripple. The inductor average current is the same as the output current, which is the output voltage by resistor. This is simple. And the current ripple, we can use the first formula and then change it by using the frequency to get the final result of current ripple. Now we look at the exercise 2. We have V in equals 800 voltage. The out is 360 voltage, frequency 5 kilohertz. The voltage ripple 0.36, and the current is 3 ampere. We need to define the inductor and the capacitor. Still we use the first formula, but we need to change it since we want to calculate the inductor this time. We bring the inductor on the one side, and the other side just change the duty and the time cycle. Then we got the L. About the capacitor, we have the third formula. We simply put all the values in it and to get the final values.